Hello everyone, welcome to Math Archives. In this video, let me have to discuss about the Fourier series definition both in pi form and L form. So this is the general Fourier series representation of any function defined in the interval 0, 2 pi. In pi form, we have two intervals most probably we have discussed, that is one from 0 to 2 pi, another one is from minus pi to pi. So now we have look at the general Fourier series representation of given function in an interval 0, 2 pi first. So let f of x be a periodic function and satisfies Dirichlet condition in the closed interval 0, 2 pi. Then the Fourier series of f of x is given by f of x is equal to a0 divided by 2 plus sigma n varies from 1 to infinity an cos n x plus sigma n varies from 1 to infinity bn sin n x, or you can write this as f of x is equal to a0 divided by 2. You can take summation as common and take it outside. So an cos n x plus bn sin n x. You can write like this too, both are equivalent. Okay. So here a0, an and bn are constant, are Fourier coefficients. These constants are calculated by make use of the Euler's formula. So where a0 is calculated by make use of the Euler's formula 1 divided by pi integral 0 to 2 pi f of x dx, and an is calculated by make use of the formula 1 divided by pi integral 0 to 2 pi f of x cos n x dx, and bn is calculated by make use of the Euler's formula 1 divided by pi integral 0 to 2 pi f of x sin n x dx. So after calculating all these values for the given function, substitute in this general Fourier series representation of the function of this form, you will get a Fourier series representation of any given function defined in an interval 0, 2 pi. So this is what the general Fourier series representation of any function defined in an interval 0, 2 pi. Along with these three are the formulas we are going to use for calculating the values of a0, an and bn. The next one we have to say is, suppose if the function is defined in an interval minus pi, pi, instead of defining the function from 0, 2 pi, suppose if the function is defined in an interval minus pi, pi, here both of them are under the category of pi form. Okay. So look at here, the length of the interval also here minus pi to pi, the length of the interval is 2 pi, isn't it? Minus pi to pi, which means minus pi 0 plus pi. What is the length of the interval? 2 pi length. 0 to 2 pi means 2 pi length. So length of the interval should be same, only the interval will be is different. So instead of the function defined in 0, 2 pi, suppose if you are having any function defined in interval minus pi, pi, so then the general Fourier series representation of the function is of the form f of x is equal to a0 divided by 2 plus sigma n varies from 1 to infinity an cos n x plus sigma n varies from 1 to infinity bn sin n x. Here itself a0, an and bn all are constants. The series representation is same for both for 0 to 2 pi and minus pi to pi. Only the difference in calculating the constants, that is values of a0, an and bn. So look at here, a0 is calculated by make use of the formula 1 divided by pi. Here the interval is from minus pi to pi, whereas from 0 to 2 pi here you have 0 upper limit 2 pi. That is the only difference. Okay. So 1 by pi integral minus pi to pi f of x dx. An is calculated by make use of the formula 1 divided by pi integral here itself minus pi to pi. In 0 to 2 pi here you have 0 to 2 pi. Okay. f of x cos n x dx, and bn is calculated by make use of the formula 1 by pi integral from minus pi to pi f of x sin n x dx. So the difference between minus pi to pi and 0 to 2 pi Fourier series representation of function given in any one of the period is, for calculating the Euler coefficients, the interval is from 0 to 2 pi for any function defined in an interval 0 to 2 pi. Here for minus pi to pi means you have to take the interval limit, that is integral limit from minus pi to pi. That is the only difference. Okay. So next we move on to, suppose instead of defining the function of in the pi form, so let me move on to next L form. This is another case we are going to discuss later. Now suppose any function is defined in an interval, that is 0, 2 L. Okay, or it may be defined in an interval minus L, plus L. So these two are under the case of L form. So most of the cases we have to discuss under L form in the interval of 0 to 2L or minus L to L. So here itself f of x be a periodic function and satisfies Dirichlet condition in the interval 0, 2L. Then the Fourier series of f of x is given by f of x is equal to a naught divided by 2 plus sigma n varies from 1 to infinity a n cos n pi x by L plus sigma n varies from 1 to infinity b n sin n pi x by L. Or you can write this as f of x equal to a naught divided by 2 plus sigma n varies from 1 to infinity. You take sigma as a common term, that is common term, and outside of these two, that is a n cos n pi x divided by L plus bn sin n pi x by L. Okay, so both are equivalent, right? So here a naught, an and bn are Fourier coefficients. So these can be calculated by making use of the Euler's formula, that is a naught is equal to 1 by L integral 0 to 2L f of x dx, and an is equal to 1 by L integral 0 to 2L f of x cos n pi x divided by L dx, and bn is equal to 1 by L integral 0 to 2L f of x sin n pi x by L dx. Suppose instead of the function defined in an interval 0, 2L, if a function is defined in an interval minus L, L under L form, so we are having general Fourier series representation same as that of 0, 2L, only the difference is for calculating the constant values. So instead of having the limit from 0 to 2L, here you have minus L to L. That is the only difference between minus L to L to 0 to L. Okay, Fourier series representation should be same. For calculating a naught 1 by L, instead of having 0 to 2L, here the interval is of from minus L to L. So here you have to take minus L to L f of x dx. A n is equal to 1 by L integral minus L to L f of x cos n pi x L divided by L dx, and bn is equal to 1 divided by L integral minus L to L f of x sin n pi x divided by L dx. So under Fourier series we have to discuss two cases. One is under pi form, another is under L form. Under pi form we have two cases, that is either the function is defined under 0, 2 pi or minus pi, pi. Under L form the function is defined under the interval of 0, 2L or from minus L to L. Okay, so hope you got a clear idea about the definition of Fourier series in detail. Along with these formulas, keep these formulas in your mind. Thanks for watching. See you all again in my next video.